Hello everyone, welcome back to ECE350. This is chapter 3, vector analysis. Today we're going to talk about three coordinate systems, Cartesian coordinates, cylindrical coordinates, and spherical coordinates. You have seen Cartesian coordinates before. Actually, you have seen all of them before because you had courses like your calculus courses, geometry courses, and also you have engineering math. So you have seen all of them before. In a Cartesian coordinate systems, if you have dl in your coordinate systems, dl is basically the smallest distance possible. So that means it will be a combination of three other things like dx, dy, and dz. So you have three vectors adding together here to find the vector dl, right? And also another thing is that you may have not learned is called differential area vectors. So this is the area, right? Dx, dy is an area. So there is a vector on that area. It's called dsz because it's z direction. So z hat dy, dx, dy. This is called differential area vector for dx, dy. And same thing over here on this side. And this is the area. This is the volume. This is the volume actually. You can multiply all of them and on the other one here. So if you try to find on the other side over here, it will be basically negative x hat dy dz, right? And if we try to find one on down here, it would be negative g hat dx dy, right? So we call differential area vectors. All right, and there are two other coordinate systems, cylindrical coordinate system and spherical coordinate system. In cylindrical coordinate system, you use r, phi, and z, and spherical you can r, theta, and phi. We're gonna identify who are they. So here, your r is a vector in the radius, z is the vector in the height, and phi is the angle rotation in counterclockwise is the vector in that direction. All right. So if you have a smallest possible slice out of your cylindrical cylinder, you will get something like this, right? So over here, this is your smallest arc. So r d phi because this is the d phi right here, right? Right, and this is the smallest slice of the radius, and this is the smallest slice of your height, right? So dz, dr, r, d phi. So if you're trying to find this area, particularly here, this area over here, which is the surface, round surface, that would be multiplying height with this arc here, right? So you're multiplying height with the what do you call it? Right here, height with the arc r d phi, and in direction is in the radius direction, in the radius direction. So, and you can find the others. And if you try to find the volume, you have to multiply all three dimensions over here. So dv. So dv is the smallest volume possible, and dsr is the smallest. It's a differential area vector, and only ds, if you try to find only ds over here, which is the surface, round surface area, is r d phi dz, right? So that is for the cylinder. If you try to find the unit vector in any direction, unit vector is the vector over vector magnitude here, right? So what is the vector over here? This vector over here is basically, if you do the vector addition over here, that becomes r hat r0 minus z hat h, and if you divide that by its magnitude, you got the unit vector. And this is a simple problem here with the cylindrical coordinate system. You have a part of the cylinder, and we're trying to find the round surface area for that particular part. That particular part goes from 30 degree to 60 degree, and your height 0 to 3, right? So try to find that. You have to find the smallest possible area over here, which is ds. I know that ds is for r, d phi, dz, right? To find the now area for the whole area within the limit, I have to integrate that over phi and z. So I'm integrating over phi and z over here. So phi goes from 30 to 60, and z goes from 0 to 3. If you integrate that, you get the area for that particular part. And for the spherical coordinate system, again, if you take a small area possible here, then you have all three dimensions here. This is your part of the radius, dr, and this is your r sine theta d phi, and on this side here again is an arc, so it's r d theta, right? Again, theta is going from around the z-axis from one side to another side, so that I can go theta could your limit could be 0 to pi, and your phi is go horizontally all over, so phi limit 2 pi to 0, right? So now with these three, if you multiply all of them, you get the volume, smallest volume possible. If you try to find the area of this guy over here, this area over here, so if I bring it over here, this area is, let's say, is ds, it would be multiplying this guy with this, right? So it would be r squared sine theta d theta d phi, right? So that's the area right here, right? So these are the two important things, the volume and the area on the surface. So if I do a quick example problem here, we're trying to find the surface area between 30 and 60 degree angle, right? Between 30 and 60 degree angle. So, and that area, look at here, this area over here, it goes all around, right? It's goes all around. So that means your phi should go from 0 to pi, and your theta should go from 30 to 60. So look at here. So r squared sine theta d phi, that's the ds we just showed you on the other side, integrating that over the theta limit, which is 0 to 60, and also phi, which is 0 to 2 pi. If you do that, you'll get this area over here. Now, we're trying to see that, find the charge in this volume here. How much charge in this section, right? In this slice. So charge density is this one here, and we have to multiply that with the dV to find the total charge in that area of dV. Then you have to integrate that over the volume limit we have. So we have the three limit now. We have theta, phi, and also your radius. So phi, theta, radius, all three, and this is the parameter we got from here. And if you integrate that, you'll get this much charge over there. Okay. So this, if you know what you're doing in any coordinate system, you can basically apply integration to find the volume, area, or charge in that particular volume, or even in that particular surface, because if you know the surface density of the charge. One of the technology we use every day is GPS. GPS use satellite to solve your location problem. So location problem have X, Y, Z as well as your time. So you need 4 equations to solve 4 unknowns. That's right here. So you need at least 4 satellite to solve a particular location problem. That's all for today. We're gonna get to the next lecture, which is basically vector calculus.